Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this lecture, I will continue discussing the method of k-nearest neighbors. As you remember, in previous lecture, we learned how we can implement k-nearest neighbor method for classification in Excel. Now I will show you how we can implement the same method using Analytic solver. And I will demonstrate that on the example of the file called Optiva file, which we last time we did the partitioning with oversampling. I want to remind you that all these classification methods and predictions or estimations, which we will discuss, they all start with partitioning, because first we have to partition data into 3 sets: testing, validation, and actual training, validation and testing. So training set is used to train the model, so model will learn from the actual data. Then the validation set is used to compare different models which were trained on the same testing set and see which one is the best. And then finally, the testing set is used to evaluate the efficiency of the best method, which we came up with testing on validation set. So the file which we are about to open and start doing on k-nearest neighbors method, this is already all partitioned, and that's what we did during our one of our previous lectures. So let me switch to Excel and open. So this is the file, Optiva file, which contains information lots about, let's see how many, lots of, and 43,193 customers. And for each customer, we know whether the customer defaulted on loan or not, the average balance, age, whether entrepreneur or not, unemployed or not, married or not, divorced or not, high school diploma or college. So for each customer, we have the same, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. Now, if we use, remember, I want to emphasize one more time that we cannot use this raw, just unpartitioned data to do k-nearest neighbor classification. It should be partitioned, and we did that last time. And actually, this on this tab is the same data that partitioned with oversampling. Now, what I will do slightly different, which is discussed in the textbook, is that in addition of just showing you how to implement k-nearest neighbor in Analytic solver, I will also demonstrate how we can use k-nearest neighbor for classification, because the whole purpose is to be able to classify new customers, whether they will default on loan or not. That's why I created, let me show you, I created a new, so these are new customers. I just generated new customers which are not part of that data set, and I want to use k-nearest neighbor to classify these customers, whether default or not. So these are new customers. There are 2 ways of doing it. The way I will do it right now is I will copy this entire worksheet, right click, move or copy, create a copy, and I will copy this worksheet to my original data file. Click OK. Now it's right here. So this was my original data. This was the same data after partitioning. And I added another worksheet with the data about new customers. And this, I want to be able to use this method to classify all these customers. So what we'll do, everything which I'm about to do is describe step by step in my PowerPoint presentation. So first we click anywhere inside of the partition data. I want to repeat this one more time. Some students sometimes click here and try to do k nearest neighbor and it's not working properly. So we have to go to the partition data, click anywhere inside of this data set. Then we go to the data mining. Then we select classify because we want to classify. And we want to use k nearest neighbors method to classify observations. No, actually, originally, let me. And first, before doing this video, I checked that everything is working properly. That's why my data, the variables were already here. This is originally what you should get. So this is the list of all data, all variables. Now I will select all those variables which will be used in classification. So those, I will select all of them except lone default because this is not for classification. This will be the variable which will be used as an output variable. So I will select all variables. Pay attention, this record ID and customer ID, these are not variables, these are just labels. So I selected all of them, move to selected variables. Then I select lone default and move to output variable. So I want to do classification for this variable, Down here, basically I will keep the default because we will have only two classes, class 1 and class 0. So class 1 we'll consider as our success class. Remember, class 1 is default in our case. Also, default cutoff value is 0.5. I will keep this cutoff value. Remember how cutoff value is working. It works when you want to decide how to classify new observation. So it looks at the k nearest neighbors, checks the proportion of all class 1 members within those neighbors, and then if that proportion is equal or more or greater than the cutoff value, then new observation will be classified as class 1. Otherwise, it will be classified as class 0. So I will keep this default cutoff value. Then next. Now, there are two options in here. Either I can say fixed k and specify which number. So if I do this way, it means that I want to do 5 nearest neighbor calculation or classification. But the thing is, I don't know which one is better. One nearest neighbor, 2 nearest neighbor, 3 nearest, which one is better method? That's why it's better to ask solver to try to check, first calculate when k is 1 and then when k is 2, when the k is 3, up to 10, for example. I will go up to 10. I will click here. And by doing this, I am asking Analytic solver to do this. Apply, first do when k is 1, then when k is 2, then when k is 3, up to 10. And then among those, to select the best k. And the best k, it will be the one which has the lowest misclassification level. So that's the way we will do it. Then we'll go to next. Here we specify which type of reports do we want to get. I will keep default. And this is the key part here. Remember that we added a new worksheet with new data about new customers, and we want to be able to classify those customers. In order to ask Analytic solver to do that, I will click this box which says in worksheet. Why I'm clicking in worksheet? Because my new data is in worksheet. By the way, as you can see, you can even have your new data in the database and then go and get new data from database and classify here. So let's click in worksheet. When you click in worksheet, then we have to go here and say select which one is my data source. Remember, my data source was, this was the worksheet which called new data to predict. This is the one, new data. So I'm selecting it. And as you can see, Analytic Solver jumped to that worksheet and listed all variables within this worksheet. So these are the variables within this new worksheet, and these are the variables which I selected based on the original data. Because this worksheet new data can be created by completely different people, the names may be different. Now, in this case, I selected names exactly the same, but in general, if names are different, then we have to specify which name in new datasheet corresponds to which name in the original data. In this case, names are the same. That's why I will just click match by name. And as you can see, Analytic Solver nicely matched all those names. Age is matched to age and so on. So we are basically done. Now we'll click finish and let Solver do its job. And in a few seconds, it will generate lots of worksheets with lots of information. See how many worksheets it generated. Let me just show a few of them. I have a detailed interpretation of several outcomes from these worksheets on the slide. So instead of just reading from the slide, it's better you go and check all those outcomes. But I will show you some of them. For example, the first one, which is this output. Remember, we asked to do for all Ks from 1 to 10 and select the best one. So Analytic Solver did, and for each K, it calculates also percentage of misclassification and selected the best one. It appears that the best one is when K equals to 1. In this case, the misclassification percentage is the smallest. So after selecting the best K, the rest of all calculation is based on this K. Now, here you can see three similar tabs. K nearest neighbor classification for training, for validation, for test. All of them contain information about the precision or accuracy of classification. And as we remember, the basic measure was confusion matrix, right? And then several other metrics based on the confusion metrics, like accuracy, specificity, sensitivity, and so on. So that's what it generates. Look at the confusion metrics here. There is not a single misclassification, because 0 plus 1 observation was classified as 1, and the same in here. None of class 0 were misclassified. The reason is very simple, and the reason is because, remember, the method, this key algorithm, was trained on training set. Now, if you train the method on training set and then you apply the same method on the same training set, obviously the result will be perfect. And that's why we got the perfect result in here. It will be not the case when you look at the validation set, so it's not as perfect. Now we have misclassifications here, and for testing sets also we have several misclassifications. Now, one important thing which, remember this was our input, new data, and we were trying to classify all these customers, new customers, either class 1, which is default, or class 0, which is not default. And also the Analytic Solver already did it for us. And this is the tab which says new score. And here, if you scroll down, you could see, these are my new customers from that tab which I just showed. These are my customers. I have 30 of them. And so these are those new customers, and next to it, it says prediction. And this is the prediction for customer 1, prediction for customer 2, prediction made by Analytic Solver using K nearest neighbors method. Let me just put these predictions next to the actual data. So you can copy this and I'll go to, this was my new data which we were planning to predict, and the prediction is done already. And I'm just pasting the data from there. And this was the basic result. We were able to use K nearest neighbor to classify new customers as default or not default. For example, this customer is classified as default. So the bank may think whether it's riskier to give a loan to this customer. If it's not default, which means software found that this is less riskier than the ones. So this is how we can use Analytic solver to do K nearest neighbors for classification. And we went through all steps and we were able to classify a new data. Pay attention, as I mentioned once, this last part, being able to classify new data using K nearest neighbor, it's not explained in your textbook at all. So therefore you have to carefully watch this video and read the descriptions and interpretations on the PowerPoint slides. This concludes my today's lecture. Have a nice day. Bye-bye.